Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ont. In this tutorial video, I'll go through this 5129. This is for the combined science for the Cambridge International Curriculum, which combine the three sciences into one subject, and as such the contents within are a bit more diluted. This is the work one for the acid, bases and salts topic, tutorials of which would have been in the topical playlist within. In this first question, we have acid indigestion. When you have high levels of stomach acid, you know that stomach acid mainly contains hydrochloric acid, which is a strong acid in the stomach to help us to digest food and stuff. And you get gastric as a result of a pretty high concentration of HCl, hydrochloric acid, in your stomach. Or when you get indigestion, acid indigestion, as a result too much stomach acid, this hydrochloric acid, too much of it, causes your stomach intense pain. So what you can do is you can take an antacid tablet. This antacid tablet essentially reacts with the acid, and therefore it prevents the stomach from getting too acidic, and therefore it can help to soothe, it can help to reduce or decrease or alleviate your pain in your stomach. So one type of antacid tablet contains a mixture of these sodium hydrogen carbonate, calcium carbonate, as well as magnesium carbonate. You might not be very used to this idea of hydrogen carbonate, but then you already would have been used to this idea of carbonate. So carbonate, from year 9 chemical formula of ions, there was a table of all these polyatomic, these things that contain more than one atoms. This is CO3, 2 minus. 2 minus is the charge of the ions, so that is the charge of the ions. Ion is charged, and here you have got 1 carbon and 3 oxygens. I mean, these are just in terms of chemical formulation, things you would have been used to from last year in year 9. For instance, you have calcium carbonate, calcium being a group 2 metal. If you are a group 2 metal, from the periodic table, you will have lost your 2 outer shell electrons to form a +2 ion from the metal. CO3, 2 minus. 2 and 2 is what you call the valency. Valency is basically the combining power, which is based on the value of the charge. And they were all from the year 9 where we did the crisscross and we exchanged the valency. The 2 on the right goes to the left, the 2 on the left goes to the right. And of course, this is not in the simplest form. You need it in the simplest ratio. 2 and 2 can be divided by 2 on both sides, and this gives you 1 and 1. And now it means you have 1 of the calcium 2 plus and 1 of the CO3 2 minus, such that the formulation for calcium carbonate is CaCO3, magnesium carbonate is MgCO3. Because magnesium is just above calcium in the periodic table, you're going to have Mg2 plus, calcium 2 plus in the periodic table. From the periodic table, the formula of the group 2 ions, together with CO3 2 minus, carbonate ions. These are carbonate ions, again from year 9 chemical formula of ions. You get a gas given off when you have antacid tablet reacting with the hydrochloric acid. If you think about metal carbonate, there are metal carbonates in here. There are the calcium carbonate, magnesium carbonate. In fact, this hydrogen carbonate is going to react in a similar way as the carbonate. So when you get metal carbonate plus acid, this is part of the acid, base and salt topic. Metal carbonate plus acid. Acid will give you the salt, so you get the metal salt. You started from the carbonate, so you're going to get carbon dioxide gas, as well as water. The formula for water is your H2O. The formula for carbon dioxide is CO2. 1 carbon, 2 oxygen. Carbon dioxide is a year 9 chemical formula. Well, not just chemical formula, but also in the bonding. In the bonding topic, year 9 chemical bonding, you learn about covalent bonding. Oxygen with 6 electrons in the outer shell, because oxygen is a group 6 element with 2 6 electronic configurations, therefore 6 electrons in the outer shell. Carbon 2 4 with 4 electrons in the outer shell, because the group 4 element uses all 4 out of 4 valence electrons for forming covalent bonds. Oxygen just need to share 2 electrons to complete the outer shell, so each oxygen share 2 of these dots, meaning to say you still have 4 more dots on each oxygen, because you have 6 of these dots originally. Now you still have 4 more dots. If I want, I should really be able to show you that these are the dots in green color so that it is less confusing. So that is 1 covalent bond, 2 covalent bond, 3 covalent bond, 4 covalent bonds. I can draw them as line like these from year 9. Carbon form 4 covalent bonds. Oxygen in group 6 shares 2 electrons each. They form 2 covalent bonds from each oxygen. Anyway, this gas that you expect to produce is what you call carbon dioxide gas. Describe and explain the change in appearance of the lime water. Lime water is what you use to test for carbon dioxide. So what happened with that is your lime water will turn milky or it will turn cloudy. Essentially, it goes from a solution to become a white precipitate or white solid. That is the appearance of milky and cloudiness from the lime water. That is a result of the reaction produces carbonate. So the reaction between the antacid, which contains the carbonate, metal carbonate, and the acid, the dilute hydrochloric acid, produces, if you don't like produces, you can use the word forms, carbon dioxide gas. So carbon dioxide gas will react with lime water and you will get the milky or the cloudy or the white solid, which is white precipitate. So this student uses excess acid. If you use excess acid, that means, well, you know, all the antacid is going to react and dissolve completely because the acid is more than what you need. So all the antacid will have reacted. State the names of the 2 salts. You want the salts. So the salts came from the reactions of acid and the carbonate. You have the calcium carbonate, which will give you the calcium chloride because you started from hydrochloric acid. So HCl is what you call hydrochloric acid. The hydrochloric acid is going to give you Cl minus salt. This is called chloride salt. So what is the metal? The metal earlier was calcium carbonate. So you are going to get calcium chloride. The other metal carbonate was magnesium carbonate. So you're going to get magnesium chloride. Of course, we also had another one, which I mentioned earlier. The hydrogen carbonate will behave similarly like carbonate. Although you don't learn in details, you should know that it behaves like carbonate. So sodium hydrogen carbonate will also give you sodium chloride. So you have another answer, which potentially could be accepted. There will be your sodium chloride. So in whichever order, as long as you have 2 out of 3, you have gotten the 2 marks there. In this second question, so the science class is trying to make magnesium carbonate. You're trying to make magnesium carbonate and you want to make it by precipitation. Precipitation means solution and solution, solution plus solution. And what would that give you? They give you insoluble precipitate. They give you insoluble solid. As you could see from here, these are aqueous and aqueous. Aqueous and aqueous means that you have solution. Solution means dissolve in water, dissolve in distilled water. If you look on the right hand side, you will see the appearance of a solid, which is your magnesium carbonate. A solid is what you call a precipitate. So when you produce a solid from 2 solutions, that process is called precipitation. It's part of salt preparation topic towards the end of the lecture tutorials, which was covered in lesson. State the meaning of the symbol. The AQ refer to aqueous. Aqueous means dissolve in distilled water. So you could write either of them. They mean the same thing, but aqueous would have been the easier option. The S there refer to solid. You could also write it as precipitate, but of course the S is easier to just think of it as a solid there. Now this teacher give a student 50 cNq of magnesium chloride. And now, how much of the potassium carbonate is required to react with all the 50 cNq of magnesium chloride? Well, if we look at these, this is a solution and solution. So this is 1 of the MgCl2 reacts with 1 of the K2CO3. Now, if this is the 50 cNq of the MgCl2, 50 cNq of the MgCl2 from the equation above, now we want the volume of the potassium carbonate. So if you have 50 cm³ of this, you have one of it. Well, if you have 50 cm³ of this MgCl2, one of it reacts with one of it. If you have 50 cm³ of this, you will react with 50 cm³ of K2CO3, which is why the answer is exactly 50 cm³ there, based on the balance equation. Now this student begins to add the potassium carbonate solution. I want to emphasize on the idea of solution. Solution means it's soluble. Soluble because it is dissolved in the distilled water. So that means, you don't have solid at all. You just dissolve in water. These are solutions. You stir it and then you will precipitate out, or you produce a solid which is insoluble. So precipitate is insoluble because they don't dissolve in water. They come out as solid. So this student decided that she has added enough potassium carbonate. She wants to filter the mixture to remove the magnesium carbonate. Here is how her filter paper looks like. Show by completing the diagram or by describing how to fold the filter paper. Because they give us a choice, I am not very good at drawing, but if you can draw, you can draw something and then you draw something again, because you gotta fold in half and then you fold again in half. Okay, so you gotta fold the filter paper in half. So I'm just writing in words. If you can draw, you draw. And then, okay, so you see how there are 2 marks, because you need to fold again in half. Then you open up. Then you open up into a cone and fit onto filter funnel. So filter funnel is where you put the filter paper onto, and then you will pour the solution which contains the solid, and the solid will be left behind on the filter funnel. If I draw a very generic 2-dimensional filter funnel, looks like that, and then I put in a filter paper on top. Because a filter funnel has got holes in between, you need the filter paper on top, otherwise your solid will go through. So what I have there is I will collect a solution. The solution, or the liquid that passed through the filter paper, is what you call the filtrate, and then you will have solid that get left behind on the filter paper. This is what you call residue, which is left behind solid on the filter paper. The student collects the magnesium carbonate in the filter paper. This is the residue, because the residue is the insoluble solid. The insoluble solid that you filter, these are left on the filter paper. That is all year 9 definition as part of separation techniques in year 9 combined science when we did filtration. So the filtrate is collected in the beaker, because the filtrate is the liquid or the solution that passed through the filter paper. This student wants a pure sample of magnesium carbonate. She does not take the magnesium carbonate out of the filter paper, because your original solution still contains some of the filtrate, which are soluble stuff. So what should she do next? Well, she needs to wash or rinse the residue, which is the solid left behind on the filter paper, with what? With distilled water, because you want to remove all the soluble stuff. Your stuff is insoluble, so they will get left behind, but previously you had a bit of the solution which contains your mixture of solutions, and you want to ensure that it's as pure as possible. You want pure sample, so you want to remove all the soluble stuff, so you wash it with some distilled water. The distilled water will solubilize whatever is soluble and pass it through and join the filtrate, and then whatever is left behind after you wash it should be the pure sample of the insoluble magnesium carbonate precipitate, or the solid. In part E, this student wants to find out if enough potassium carbonate was added. Have you added enough or not? How can you do this using the filtrate and a few drops of the potassium carbonate solution? What does your filtrate contain? Your filtrate is not the insoluble magnesium carbonate solid. If you look back at the equations, let me just copy paste the equation from earlier. So that was the equation. MgCl2 equals K2CO3 equals, giving you that. What you're left behind is the KCl. Okay, what you're left behind is the KCl. And how can you use a few drops of the, what did they say? What can you do to use a few drops of the potassium carbonate to the filtrate? So what does your filtrate contain? What was the question again? Enough potassium carbonate was added. Okay, so if the filtrate still contains potassium carbonate, then what is inside the filtrate? Then if the filtrate still contains potassium carbonate, using the filtrate, our filtrate should contain the remaining things. Our filtrate should contain the remaining product as well as whatever that's in excess, the MgCl2 aqueous and the K2CO3 aqueous, which means that if your filtrate contains any of these and then you add in some potassium carbonate, if you don't get any more solid, so that means all of these have been gone to these. But if you still get solid, that means you haven't added enough of these because some of these still remains. So your job really is there still MgCl2 remaining? Is there still MgCl2 remaining? If the filtrate still contains remaining MgCl2 aqueous, so see the equations above. If you still contain this much, okay, i.e. not enough potassium carbonate added, then what will we see? Then when we add a few drops of K2CO3 aqueous to the filtrate, what will we see? We will get further or more solid or precipitate forming, i.e. that is the magnesium carbonate solid from the equations. But then if you had added enough potassium carbonate, that means all the MgCl2 already gone to form the insoluble residue, which you already filter. So that means there should be no longer MgCl2 remaining here. And if there's no MgCl2 remaining here, that means when you add the potassium carbonate, then you should have no more precipitate. So how can she do this? If there is MgCl2 remaining, then you will get precipitate. If there is no MgCl2 remaining, then you will not get any more solid because you will not precipitate out the MgCl3 solid because there won't be any more Mg2 plus since all of them will have been precipitated out anyway. Okay. The last bit of this question is about getting a pure sample of the crystals from the filtrate. The filtrate is already the solution containing water as well as the potassium chloride. So the first thing you should do is, in your year 9, you already learned about crystallization. Crystallization essay come in a few steps and you have to write down all the steps in clear detail. You gotta heat or you gotta warm the solution, meaning to say the filtrate, which contain potassium chloride solution, until it becomes saturated. In year 9 combined science separation technique, we talk about saturated solution where you have very little solvent because you have the maximum amount of the solute dissolved in the solvent, which is just the distilled water. You gotta allow saturated solution. Saturated does not mean you get solid. Do not heat until it is dry because you want to get crystals. You have to get until you are saturated solution. There is no solid. You just allow the saturated solution to cool and then crystals will form. Crystals are solid. So what you do is that you need to filter the crystals. So crystals are solid. You filter the crystals using a filtration apparatus, and then you wash the crystals. You wash the crystals with cold distilled water. Just like the earlier bit of the question, you want to remove any soluble impurities, and then you dry the crystals in between filter papers. So drying is not asked here, so you don't get marks for drying, but it is quite common. Sometimes the question will say a pure dry sample of the crystals. So after you get the crystals being purified upon filtration, it's good to dry it in between filter paper as well. That's it really for this work. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel, and follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. Thank you for watching again. I'll see you in the next tutorial video.